Hello friends, my name is Manoj Kumar from Corp IT and today we'll discuss about pod. So a pod is the smallest deployable unit in a Kubernetes. It can hold one or more container that can together on the same node. These container inside a pod share. So basically they share three things. Storage volumes make it easy for to share file between the container. Networking, they can talk to each other via the local host. Two container in the pod, they can communicate. Operating system resource like IPC. If there is any inter-process communication, they can also do that. So instead of running container in isolation, Kubernetes group them into the pod for better management. Why are so now we understand okay what exactly the pod is. Now understand why pod are important in Kubernetes. Okay. So without pod, Kubernetes wouldn't know. So the first thing, deploy container together in a meaningful way. With the help of the pod, we can manage the life cycle of a container. Using the pod only, we can scale, we can restart, and if required, we can do a replacement if something break. And also manage update in a control and a resilient fashion. When we talk about how we can do update in Kubernetes, I will show you there are two approaches like how we can do that. So in short, pod help Kubernetes turn raw container into a reliable, scalable application because you can think at like the when we running a container, there is no way to control them in a meaningful way. To in control in a meaningful or in a desired way, we use to bind it in a pod. Now let's just talk about the architecture. Okay, pod architecture core container inside a container. Basically, you can have you there are two approaches. So first you have a pod with a single container. The second approach is you have a pod with a multi container. In the later on in this video when I go to the practical section, I will show you that. So it depend upon your application to application. If your application just requires single container, you can create a pod with a single container. But if you are deploying, let's suppose a WordPress, so it required a database as well as a front end. So at that time you need to create a multiple container pod. Now the share resources, as I already discussed, that the pod will share resources uh, with the container who are in the same pod, like networking, IPC, and volume, and they are ephemeral in nature. What do you mean by ephemeral in nature? Like they are very short lived. So that the reason we have deployment and other concept. In case something happened to one pod, it will spin it up again. When we go to the deployment section, we'll talk about that. Now, pod lifecycle in Kubernetes. So it idly go for a pending. That means the system accepted that pod, but waiting for resource to or the image. Now it running. That means the container successful running. Succeed, that container finishes job and the restore policy is set to none. So it mark as a succeed. Fail. At least one of the container or couldn't start. Let's suppose you have a multi container pod and one of the pod is not running, then it could be a fall. And the another thing, let's suppose it unable to load the image from the internet, and then it also failed. Unknown, that means system unable to determine the state of the pod. Now there are two advanced concept in the pod. So the first one is sidecar pod, the sidecar container. So let's just understand from the definition what is exactly a sidecar container. A sidecar container is a helper container that run in the same pod as a main application container. So there, let's suppose there is a main application that you are running, and along with that there is a helper container that is known as sidecar container. They share the same network, storage, volumes, and the life cycle, but each container run its own process. So let's suppose container A running a process A and the container B are running a process B. You can use sidecar to extend or enhance the functionality of the container without modifying it. So you can think of, let's suppose we have a container A and we have a side container B. So with the help of a side container A, we enhance the functionality of uh, our primary container A. Okay, so you can think of it, and you can think of like what are the use cases of that. For logging and monitoring you can use it. Let's suppose you are setting up a proxy or a service mesh, you can use it. If you want to have a data synchronization, then you can use a sidecar container. And let's suppose you want to have the constant update of a configuration, you can use that. Now let's discuss about the ephemeral container. So ephemeral container is a temporary container that you can inject into a running pod for debugging or troubleshooting without restarting the pod or changing its YAML definition. So they do not appear in a normal pod spec and not restarted if they crash. That means for short-lived debugging, not regular workload. So first thing you need to understand, ideally whenever we do the debugging, we use like kubectl logs, we use the kubectl describe command in order to debug the container. But there are sometime what happen when we unable to achieve same using the uh, kubectl log or describe, probably it is not running or something. At that time we require the ephemeral container. So common use case, injecting the start of a broken pod. Let's suppose you are running a pod but it is broken, so you want to debug it further because um, your your kubectl is not working, so you can use that. Running diagnostic tool inside the same network. So let's suppose you have a pod and you want to go to the same network and from there you want to troubleshoot, then you can also use it. It debugging crash container without redeploying, so that's also one of the important. And let's suppose if you want to do that in action, then this is the command kubectl debug it, like it's going into the interactive mode. My pod, like the image name is busy-box and the target my container. Now let's talk about the pod quality of a service classes: guarantee, bustable, and best effort. So you created a container, but how we can guarantee that it will get this much of our resources? How we can guarantee that? There should be some way. So we have a limit, and like we can define in a container that this particular container should get this much of our resources, not more than that, not more less than that. So let's suppose if you created an nginx container and you define, okay, this nginx container should take this much of our resources, then it is a guarantee that if the worker node having this much of available resources, then only this particular pod will be deployed. Bustable, let's suppose you deployed a multiple container. In one of the container you define that, okay, this particular container required this much of our resources, but the another container you decide, okay, let it be whatever. So at that time it will be a bustable. And the third one is your best effort. So you did not define anything, whatever the resource available on the worker node, it will take it. So let's just summarize things up. Okay, so we already know what is a pod. Pod is the smallest deployable unit in the Kubernetes. It shares three resources: storage, networking, IPC. Now, why pods are important? Deploy container together in a meaningful way, handling scaling restart or a replacement if something breaks, and manage update in a controlled and resilient fashion. In the pod architecture, there could be three type of pod: container inside a container, like a single container we can have in a pod, we can have a multi container inside a pod. Shared resource, networking, IPC, volume. And what else? The pod are in ephemeral in nature. Now the pod life cycle, there are 5 stages. Like any pod could be in the 5 stages: pending, running, succeed, fail, unknown. Now we discuss about the sidecar and ephemeral container. To be very honest, in a day-to-day life you will not interact with these container very often, so you can have this in your mind, at least you know what are these, but you can ignore that also. Now this is the quality, pod quality of service. That is something important. Let's suppose if you are running into a big organization and you have to have everything defined, that how, where these resources are going. So in these cases you need to limit your part. So this is the theory part. If you want to see all these topics in more detail, you can also look into it. Everything I took it from this article only. This I wrote only this article. Now everything is done. Now let's go to the practical section. Okay, so first thing first, let's just see what are the running container, what all are the running container we have. So how we can do that? kubectl get pods. So as of now, it is stating in the current namespace there is no uh, pod which are running. So let's just create a nginx pod. Kubectl run nginx demo hyphen name equal nginx. So basically what we are doing, we creating a nginx container. The name will be the nginx demo and the image it is using, it is nginx. So let's just hit enter. So what is stated? Okay, so my bad, it should be image, not name. So it stated is created. Okay, let's just verify that. Kubectl get pods. Okay, so we can see we have a one pod and it is in running state. If you want to have more detail about that, then you can add a parameter -0 wide. So you can see there are other detail also, the IP of this container, which node it is, and these things which are we did not define, that the reason this is not there. Now let's just try to describe this pod. Kubectl describe pod, which pod? Nginx. So what we can see it over here. So let's just see this. So name, this is the name of our pod. This is the namespace where exactly in which namespace with this pod is priority 0. So we think we talk about the quality of service. This is one of the thing. Okay, then the another thing about this pod. Now here comes the interesting part. What are the containers? So there is only one container named nginx demo. Image we use nginx, from where it pull the image from. This is the hash value of there, and from there it pull the image. Is there any mount point we have? Yes, this is the default mount point that we have, that is created by the Kubernetes itself. These are few conditions that we have. We'll discuss this in the later on this course itself. See, you can see also the quality of service is best effort. And what is the best effort if you can see? No resource limit at all, lowest priority, first to be evicted. So if something happens, this is the container that will be evicted first. Okay, so now we already run that. Now let's just talk another things. So let's suppose if you want to have a log of this pod, like if you want to see what all are the logs for this, then you can do that. Kubectl, what happened? Yeah, our name is nginx. Wait a minute. Kubectl get pods. I believe I added the demo also. Yes, that the reason it is not coming up. So you can see the logs of this container also. So these things will help you in the live troubleshooting. Okay, now what else we can do? That let's suppose we want to, it's a multi container pod. So you want to see for a one particular container what are the logs for that. So you can run this command, and in the C, let's suppose in this container we have this container. Okay, I will show you a multi container demo also, so you can also do that, but it's like already a one, so that's the reason it's kind of a not working. And let's suppose if you want to exec into this pod, okay, you want to see what is the content, like basically log into this machine. Okay, so you can see we log into the nginx demo. Okay, if you do ls, see these are the point, these are the entries that we have. So all those things you can do it for the live troubleshooting. Let's suppose you deployed your nginx server over there and something is not working, then you can, with this command, you can log in into that particular container and you can execute and test the stuff. Now let's just see about a multi container pod. Okay, so how we can do that? I just have a YAML file with me. So if you do cat multi, so you can see there are two containers that I have. One is nginx, one is sidecar. Okay, let's just run this. So how we can run it from the YAML file? Kubectl apply -f multi container. It just created. How we can verify? Kubectl get pods hyphen 0 void. So you can see our pod is running. There are total two pod, and one of the pod is only running, and the status is crash loop back. Okay, let's just understand why exactly it is the case. kubectl describe pod, and this is our pod name. So we can see the events. So what it is stating, it assigned a node, it pulled the image, successfully pulled the image, created a container, started the container image already present on the machine because I already tested, created the container, and back of restarting failed container sidecar in the pod this. So basically what it happened, so busybox is a container that need to run constantly, but in our case we did not define anything what it need to be done. So basically just busybox just created, and it find out okay nothing I need to done, so he just stopped. So due to that it is happening. So if you can see the describe of that, then you can understand there are two containers. One is sidecar updater that we define on that file, and the another is the main app. The main app we define nginx. In the sidecar update we define the busybox. So you can like that you can have your multi container pods. Okay, now what else we can have, we can think of a guaranteed QoS thing. Okay, so we can have vi nginx case guarantee demo.yaml. So basically what we are doing, we created an application named nginx, this image we are using, and we requested 200 MB of CPU, and memory should be 200 megabyte. This 200 MB is a value, it's not megabyte, and we limit it like this is we are requested, and we don't want to go beyond this request. Okay, so we define that wq. Now let's kubectl apply hyphen f k8. It stated our container running. How we can verify? kubectl get pods hyphen 0 y. So we can see our container is running. Let's just describe that. kubectl describe pod QoS guarantee. So you can come, if you come over here, the QoS class is guarantee. Why it is guarantee? Because we define the value that we need only this much. We don't need much more than that. So if you can see, the limit is also there, the request is also there. Let's do one thing. Okay, kubectl get pods kubectl edit pod. I won't suggest you to do that, like we are basically changing in the live. Okay, so we requested it, but let's just remove the limit. Okay, what happened? Okay, okay, it is running. Let's just verify if the changes that we made, no, the changes did not made, because we still see that. So let's do another thing. I believe we have that file. Yes, so we do vik8s and we'll remove the limit. Okay, that we requested that much, but we don't set a limit. Okay, then again if you do kubectl apply, what happened? Forbidden port update. Any? Okay, it's showing some error with with the limitation. The reason why it is stating, because we already running that and we are modifying it. So, or I believe we cannot do that. See, so basically now what I did, I just deleted the existing create container and just created new. Let's just describe it. See, here the queue is bustable. So this is what we want to test it. So basically here we request this much, but we did not set the cap like till where it should go. So that's also you can verify it from here. So I believe we almost cover everything. We cover like how to run a nginx pod, how to get information about the pod using the kubectl get pod command. We also see how we can describe a pod. We also see how we can get a logs of a pod. We also see how to exec or get inside a pod. We also see the multi-container pods, like how we can have a pod with a multiple container. And the similar in the similar way, we also see the quality of a pod, quality of service of a pod. So we also see that. So that's all for this video. I know this video is a bit lengthy and there are a lot of things to cover upon. You can go with each thing one by one. In case you have any issue or something, you can reach out to me on the LinkedIn, or you can also let me on the comment. I will more than happy to assist you further. If you think, Manoj, this particular thing need to be explained better, or you want me to have another video for that, just let me know. I will create one same for you. So that's all for this video. We'll see you in the next one. Till the time, peace.